Hey guys, welcome to Intellipaat. So computer vision is a field of artificial intelligence that trains computers to interpret and understand visual world. From recognizing faces to processing live action of a football game, computer vision surpasses human visual abilities in many areas. So in this video, we have come up with this project on face recognition using computer vision to help you get started in this very interesting field. Now before we start, do subscribe to Intellipaat's YouTube channel so that you never miss out on our upcoming videos. Also guys, if you are looking for an end-to-end certification course on artificial intelligence, then Intellipaat provides just the right course to help you become the master in this field. Now before any further delays, let's get started.
So, suppose you are a computer vision engineer and a client has approached you with a problem statement in which you have to detect the faces from a set of images that they will be providing, and you have taken up this project, and these are the following steps that you have to follow while building up this project. So, these are the images that they have provided to you. These are some of the images that have taken from their dataset, and here we'll be working on Python with OpenCV. In this project, we will be using the ware cascade classifier for detecting the faces from multiple images. So firstly, you have to perform the downloading part for the ware cascade system. So here I have written download ware cascade frontal face default.xml and this raw GitHub code. These are the raw datas for the ware cascade. You have to just simply save as, and you can save it as desktop, and you have the ware cascade classifier. So now next we will be just importing the CV2 and glob. So now we will be practicing it in the Jupyter notebook. So firstly you have to import the CV2 library and glob. So I want to tell you that glob is the function which returns us the array of those file name which we will write in the next line. Like we just have to perform face detection on those images which have .jpg extension. So for that I will be writing gimage equals to glob. So here I am calling the object glob and with the function glob, and here inside the function I will be writing the star.jpg. So it will take up all the images that have extension .jpg. So after that we will detect, after getting the glob images, now we will create cascade classifier so that we can, so as it helps us in getting the face detection. It contains all the features of the images like nose, ears, face, object. These are some of the features of the image. So here we will be writing detect equals to cv2 dot cascade classifier. Then inside the braces we will be writing which classifier. We have downloaded the ware cascade frontal face default classifier, so we will be mentioning the same name, ware cascade. Okay, ware cascade frontal face default.xml. So now after creating the ware cascade frontal face default XML file, then what we will do, we will now traverse the glob images so that we can detect the faces. So for traversing we will be creating a for loop for traverse, or you can also write t image for traversing the image, t image in g image, the glob image. Okay. So now it will take one image at a time. Now in the for loop we will read the image, a particular image. So for just reading the image we will write like I have taken image equals to cv2 dot im read, and what is this reading? The t image. Okay, so after reading the particular image from the G image, now we will convert the images. These are the colored images. The image that it has read, it is the colored images. So in this face detection, we will first have to convert the colored image into the grayscale image. So it is easier for the classifier to handle the image and detect the faces from it. So for converting the image from converting the colored image to grayscale image, we will write gray image. I have written this gray image equals to cv2 dot cvt color color, and in the braces it will have this image that you have to convert it into grayscale, this image comma the we will write cv2 dot color and underscore bgr to gray gray. Okay, so after converting it into grayscale, now we will detect the faces from the images. So for detecting the faces, I will be writing the face equals to detect. I am calling this object here and with the function detect multi-scale, and it has 3 parameters. So the first one is in which image you want to detect the face. So we will be writing this gray image here, and the next parameter is the scale factor. So we have to see the value of the scale factor, as the scale factor is that value which decreases the volume of the whole grayscale image by 5% until the face is detected. So it basically what does it decreases the value of the image so that it can find the face from the image. So I am writing 1.25. The smaller the value is, the greater will be the accuracy. So I am writing 1.25, and the next parameter is the minimum neighbor. So we don't have to bother this value. Now after that, after detecting the face, now we will be describing the rectangle shape for the face. So for that, create a for loop for. Now in this braces, we will be writing all the dimensions for the rectangle like x, y, w, h, length, breadth, height and width. Okay, so after the parameter, now in face, we are actually we have detected the face, but now we have to define that face with a rectangle shape. So for that, we will be using the dot rectangle function. So here I am writing cv2 dot rectangle. Okay, rectangle. Now in this we have 4 parameters. The first one is the image that you have to detect the face image, this image that we have read it here. Okay, the second parameter is the RGB value. RGB value means the colored value. So here I am writing the x, y, and then the other parameters for the rectangle. We are basically defining the parameters of the rectangle, how it will look on the image. So we will be writing x plus w, y plus h. Okay, so after defining the parameters of the rectangle, now we will be look at the color of the rectangle. So here I am just taking the green color. So this is the code for green color. Okay, 0,255,0. Okay, so now after that the last parameter is the thickness of the rectangle. So I am giving 2. So now after defining the rectangle, now we will just show the image. So for displaying the image, cv2 dot imshow, in the parenthesis we will be writing detect. Any message you can write like detect images. Okay, and comma which image? This image. So image. Okay, so after displaying the images, now we will be defining the wait key function. What does wait key does is we will define some intervals between the images. It's just a time period that what will be the intervals between the images. So cv2 dot wait key, and how many? I am taking 200 milliseconds. Sorry, 2000 milliseconds, and we will be writing cv2 dot destroy all windows. So destroy all windows will closes all the windows based on the wait for key parameter. So here I'm writing the 2000 milliseconds, so it will destroy it for that. So here, okay, so I'm running this code. So here you can see that all the faces have been detected. Okay, so I hope you have liked this session.
So guys, I hope you found this video informative. If you have any queries, do let us know in the comment section below. Thank you for watching.